Hello, everyone. We're going to give just a little bit of time for people to file in here. But while we're waiting, just wanted to thank everyone for joining our webinar today with Dan Wahlin. And we're going to be talking about, as you can see on the screen, using TypeScript interfaces and generics to help you drive better consistency and reuse of code across your code base. So a few quick announcements before we get started. One of the most common questions we get is, will this webinar be recorded? And the answer is yes, it will. You'll be sent an on-demand link to the email that you used to register. Additionally, if you want to rewatch it immediately after, we're also live streaming to YouTube and Twitter, and there should be a replay link that you can go find there to watch immediately after. Also, at the end of this webinar, we'll be doing some Q&A with Dan. So as you have questions, drop them in that Q&A box in your Zoom window, and we'll get to as many as we can at the end of the webinar. I know for sure one of the questions that we're going to get, Dan, is about your audio visual setup, because you have one of the most crisp, professional looking ones. I know we got one last time, and I'm sure we'll get some now. So if you want to preemptively address that, feel free and get that out of the way. Right. But anyway, with that, I'll turn the time over to Dan.
Awesome. Well, thanks a lot. I really appreciate it. And welcome, everyone. Really excited to be here with you today. As was mentioned, we're going to be talking about TypeScript interfaces and generics today. So if you've used TypeScript before, or maybe haven't used TypeScript at all, we're going to focus specifically on more of the interfaces and generics angle, and then I'll have a few other things I'll throw in along the way. So I'm a cloud developer advocate at Microsoft and also a Pluralsight author. I have a lot of courses that cover TypeScript fundamentals, have some Angular architecture that's all TypeScript. And so that's kind of my angle on, why I'm doing the webinars with Pluralsight. Is worked with them for many, many years. And also blog a lot here at blog.codewithdan.com if you're interested. So with that, we're going to jump right in and talk about the agenda here. So first off, if you are new to TypeScript, you might have heard of these things called interfaces, or maybe generics, or just types in general. So by the time we're done today, you should have a pretty good idea about not only what types are and why we call it TypeScript, but also why you would use types, some of the primitive ones we're going to discuss, versus maybe interfaces, and then generics fit in a different way. So if you've already used TypeScript before, but maybe you're just a little bit unclear on why would I use interfaces, what's the difference between that and this thing called a type that we're going to talk about, what's a generic, maybe you haven't used those much, we'll hopefully clarify that for you. So jumping on in, what I'm going to do is really quickly review what TypeScript types are, why you would use them, what are the benefits, and if you've done TypeScript, you'll know this part, but I'm going to review it just in case you haven't seen this much. From there, we're going to get into the case for interfaces. And I'll have to say interfaces are probably, if I had to rank, like what's my number one reason for wanting to use TypeScript, it's probably interfaces. Now I did Java and .NET and all those things, which you do not need to do TypeScript, but they also have interfaces in other languages. And so I kind of have the benefit of using them with other projects over the years. And when TypeScript came out and I saw I could do them here with front-end code or Node.js code, if you're doing that type of coding, it was pretty exciting, actually, because you'll see why they're so powerful. And so I'll kind of make that case first. Then we're going to talk about how you can create and then use an interface. Very, very easy, you're going to see. We're going to clarify something that I know when I first got started with TypeScript was very confusing. And that was, you'll see this keyword called type, and then you'll see interface. And if you're like me, when I very first started, I was like, okay, what's the difference here? So I'm going to clarify that for you. And then we're going to wrap up with generics. And I'll also have a nice repository up on GitHub that you can go to that has tons of code if you want to practice this. So let's jump right in and talk about TypeScript types. And again, if you've done some TypeScript, then you probably know this. But if you haven't, I'm going to set the foundation real quick. So of course, we call it TypeScript because it adds types into our JavaScript type coding. And so you have things like numbers. Well, we all work with numbers, but in JavaScript, you can assign pretty much anything to a variable. With TypeScript, of course, we can lock that down to specific types, such as it's a number. It's a Boolean, a true or false. It's a string, it's an array. And then there's even other things you can do. There's any, void, undefined, and you'll see a list down here. We're not going to go into those today, but there's some other things you'll come across. Now, when it comes to typing the variables, we know we can put the variable name, colon, and then the type name. But normally when you talk or hear about TypeScript, you see things like this. You have an age that's a number. Well, that's pretty basic, right? That's a primitive type, we call it. But it's still very powerful because now I can only assign a number to age in this case. So if I try to assign a string or an object or a function or something like that, then it's not going to work. Of course, we have a string. So if we had a name and we want that to be a string, then we can assign a string type. Is loaded, Boolean. We can even do arrays, such as string arrays in this case. And these are some of the primitives that you'll see, just about every day as you work with TypeScript. And this is great, but most of us in the real world, we're working with more complex objects. For example, you might be calling out to a RESTful service, and that RESTful service gives you this data back, and you want to work with the shape of that data. Now, what do I mean by the shape of that data? Well, if you had like a customer and it has first name, last name, things like that, wouldn't it be nice if as you're typing, you could actually get really good IntelliSense or code help, and as you're typing, it could catch errors, just like it would do if you assign an invalid value to age or name that you see here. So with that, I think of TypeScript as adding guardrails. I live in Arizona, and we have a lot of canyons. So you've all heard of the Grand Canyon, but we have a lot more canyons than that. In fact, driving up to where I grew up in Arizona, there's a huge canyon called the Salt River Canyon that most people, the first time they drive through it, go, "Oh, that's the Grand Canyon," but it's actually not. It's just another one. But it's a pretty big canyon. I'm guessing if you drove off the road, it's at least 200 feet or more down. So you don't want to drive off. So of course it has guardrails. If you're into bowling, then you might have seen the bumpers they can put on the side so you don't go in the gutter. Well, all these things, whether it's guardrails or bumpers, they're kind of like, protecting us from, if it's bowling, going into the gutter or driving off the cliff if it's a canyon. And that's really what TypeScript is all about, and where interfaces can play a huge, huge role. So jumping on in here, what is an interface? Well, officially, we call it a code contract. And I'll explain what I mean by that if you're new to interfaces. Now, if you do have the benefit of working with interfaces in other languages, again, Java would be a good example, .NET and C# or VB.NET would be a good example, then the same exact concept applies here to TypeScript. So we'll clarify if you're new to this, though, because saying what is a interface? Oh, it's a code contract. You're probably like, "Hey, Dan, I'm new to this. That makes no sense." Well, give me a sec and I'll clarify that for you. All right, so let's go through a couple scenarios first to help you see the value of interfaces. So first off, let's assume that in our application, we have a banking account, a brokerage account, and a gold account. And they all have these withdrawal, deposit functions, let's call them. Well, how would we drive consistency across those? So let's just say that Jim is working on banking account, Michelle is working on brokerage account, and Tina is working on gold account. Well, if I'm the team lead, let's just pretend, how do I make sure that Jim and Tina and Michelle, they all have withdrawal and deposit? Because it'd be pretty easy for Jim to say, "Well, I'm not going to call it withdrawal. I'm going to call it, I don't know, take out or put in for deposit," right? Well, that's one way interfaces could be useful. So you're going to see coming up that for a lot of the interfaces I'm going to show you, I'm going to put the letter I in front of it. And that's kind of a .NET convention, to be real honest. It's not a TypeScript thing per se, but I'm going to leave it in here because every time you see that, you'll go, "Okay, that's an interface." Now, if I made a document that said you have to have a withdrawal and a deposit function in your code that you're working on, banking account, brokerage account, gold account. So it kind of looks like this. And if I made you sign that document like a contract, what would happen if it was like a car loan or a mortgage agreement if you broke that contract? Well, in that case, you're probably in bigger trouble, right? In our case, luckily, the TypeScript compiler just yells at you. So think of iAccount as literally like a document that says, I, Dan Wahlin, hereby agree to put a withdrawal and a deposit in whatever code I'm working on, that where I use this contract. If I don't, then the compiler has the right to basically, I don't know, come repossess my code, I guess. Come basically yell at me and say, hey, you signed the contract, you have to do this. So one way interfaces can be used is to drive consistency across your code base. Now, if you have a really large app you're working on, this can be super powerful. And as I start to dive into some live coding here, we'll show you some of this. So that would be one scenario. Now, here's another scenario. Let's take a look right here. We have a return from this get account. So we have a banking account object. It has a get property called account info, and it returns this routing number and bank number. But down here at the bottom, what type is the info that we're getting back? If you said, well, it's an object, you would be correct. But then if I said, well, what's in that object? Well, unless you wrote the code for the get account info, you probably wouldn't know what that is. Now, a lot of the more modern editors like Visual Studio, VS Code, WebStorm, things like that, they're pretty good at giving you some help as you type. But a lot of times they don't know what it is. So with an interface, this is a perfect use case where we could fix this and say, hey, I know what the shape of this data is. I know it's going to be an object with a routing number and a bank number. Maybe routing number's a string and bank number's a number. You know, who knows? That's up to you. But we can clarify this situation so that we get more code help as we're typing. So here'd be an example of doing that. Let's say that we kind of decorate this, if you will. We add a type here to account info. And we say, this is of type account info. Now, if we knew that account info looks like this, that it has a routing number and a bank number, well, now when you fire up a new banking account and you call account.accountInfo, you know it's going to be whatever this contract defines. So you know it's a routing number and a bank number. And now you're going to get great IntelliSense. And now if you start to use this info variable and you say info.route number, instead of routing number, then what's going to happen? Well, you're going to get TypeScript yelling at you going, no, that's not right. And your compile will error, basically. So this is another example where we can define the shape of data that's returned, in this case, from a property. Maybe it's returned from a method, a function. Who knows? Maybe it's returned from a RESTful API call. We can define these interfaces to help us as we're coding. All right, so that'd be another use case. And I want to point one thing out here really quick. This is not required. When we call account.accountInfo here, TypeScript, the compiler, would see iAccountInfo and go, oh, I know what that is. And so this little piece of code right there would be unnecessary because it would use what's called type inference to figure out what's being returned. Doesn't hurt anything to put it, by the way, but it would not be something you'd have to type. So if you want to save on keystrokes, you could save on keystrokes if you wanted. All right, so the type of info is now clear. That'd be another scenario. Now, here's another one that comes up all the time, and this could be with just a function, or in this case, a class constructor. It really depends on what you're doing. If you have some object that takes some settings, what are you supposed to pass in for settings, right? Like, what is that value that you're supposed to pass in right here? And right now, it's unclear. Like, I don't have any idea, and we hope there's some documentation. We know how we as developers are with documentation. It's our favorite thing, right? Not. So there probably are no docs, or if there are, they're maybe a little bit small. So fortunately, TypeScript can help us out a ton in these types of situations where we have objects that need to be passed in from other developers. We can define what the shape of that data is so they know what to pass. So let me show you an example. So what if settings was of type iSettings? Okay, and again, the I is optional. I'm doing that to make it really obvious in this demo here, or example. Well, if I told you that, hey, over here, there's a piece of paper, a document that has a title and a position in it, and that's what you're allowed to pass is those two properties. Well, now it's very clear that when I use my object, I need to pass in some type of object, like an object literal, that has a title and a position. And I can now pass that in and we could do something with that. All right. So it makes it more clear what we should pass. So let's talk about how we can create these. And there's some slides here for you, but I'm going to just jump on over and we're going to do this kind of live because I think it's a little more fun, hopefully, for you. And you can kind of follow along here if you want. If you go to TypeScriptLang.org, TypeScriptLang.org, this is where you can get all the documentation. There's a TypeScript handbook, learn more about the community, all that fun stuff. But you'll see this playground right here. So I'm going to go to the playground. And the playground is, well, like it says, it's a place we can play around with TypeScript. I want to show you one thing really quick. First off, we can come up to this tsconfig, and this would be our TypeScript compiler settings. We can actually control those. And notice the target output is ES 2017. That's pretty common these days because most of us are using Chrome, Safari, Firefox, Edge, something like that. If you still at work have IE9, IE10, IE11 hanging around, I feel for you. We will get you some help. But we're going to kind of leave this. I just wanted to show you, but we could change it. We could go back to like ES5 if you had to target Internet Explorer still. But that's what it's set up for. Now, if I come in and define, a variable, let's just do age is a number, then you probably know that TypeScript will simply strip off that type because in the JavaScript world, it has no clue what number is, at least not the type syntax that you see here. If I come in and do name and I say string, then of course it's going to strip it off. Now, the reason I'm pointing this out, and the reason this is airing, by the way, is there's a window.name and it thinks I'm conflicting. So let's call that maybe last name. So we get rid of the red. And you'll notice that it strips everything off. So this is the raw JavaScript. This is ES 2017 JavaScript that would be actually sent to the browser. Now, that's important with interfaces. Interfaces, I like to say they taste great, 0 calories. And what I mean by, the IntelliSense tried to help me out there, calories. All right. The reason I like to say that is, first off, it's kind of fun to say. Tastes great, 0 calories. But that's truly how interfaces are. They help you a lot. That's the taste great. But they have 0 impact on runtime. They will add nothing to your bundle size. So we're all worried about, how much JavaScript we're sending down to the browser. With TypeScript, you don't have to worry about that. So let me show you an example of an interface. First off, all we do is we type the word interface. Now, let's say we wanted to do that settings that I showed just a little bit ago, right back. Let's see where that was, right here. Settings with an I title and an I position or something like that. Then I could say either I settings or just settings. A lot of people in TypeScript will just name it. But if you use classes, some people put an I. Some people are pure function-based, some use classes. So it depends. I'll let you choose. But now we can come in and we can say, all right, there's a title. And let's say title is a string. And then we have position. And let's say for now, it's just a string as well. Maybe it was actually an object, which I could show you how we could do. Now, if we had a function called, I don't know, create object, and it takes some settings just like that, and that's all we did. Well, now, what is the data type of settings? And first off, you'll notice because of my compiler settings, it's going, hey, I don't like this, Dan. You declared settings as an any. Okay, so we could fix that. We could come in and say :any, any. And the reason, by the way, that setting is on is you'll notice no implicit any is checked right here. So if you're not familiar with that setting, this will lock you down so that you can't just define like a parameter or a variable without a data type or without an assignment. So that's why that's on. Now I could turn that off, but I normally don't because I like the guardrails. I like TypeScript telling me, hey, Dan, you're about to drive off, the canyon, the road. We don't want to do that. So this is good, but not very, because if we come down now and say create object, look what I'm supposed to pass now. Okay, I know it's a settings object, but what's in the object? Well, this is where interfaces come in. If we come in and say it's of type settings, now watch what happens. Let's say, oh, I thought settings was like 5 or something like this. Okay, and let's say that this just logs, and I'll show you the benefit of the code help you'll get. Watch when I type settings in here. Notice when I hit dot, I see position. So let's do position and maybe title. We'll just log that out. Well, if I pass 5, I broke the contract. We said that you have to pass a settings object. Now, you'll notice I can come in then, do an object literal. We could say title is : my title, and position is, I don't know, left or something. Okay, now we're good. But watch when I make a typo here. Let's say I do title and I forgot the E. Notice that we get the guardrails popping up, or the bumpers, if you like the bowl again. This is the benefit of TypeScript. They taste great because they help you, but look at the code over on the right. Now, it's still going to generate this, even though that's wrong. So let's fix that. But notice the interface has 0 impact on our runtime performance, 0 impact on the size of our bundles. It's never loaded in the browsers. So interfaces are development only. They're TypeScript only. The compiler will strip them out once it creates the JavaScript that's actually going to run in the browser. And that's a huge benefit. Now, you can imagine that we could also use this for other scenarios. So let me just bump this down here. And let's say we had a get customer function where maybe you pass in an ID that's a number. And then this uses fetch or Axios, or if you're an Angular HTTP client, something like that, to actually call a RESTful service. Well, whoever calls get customer, how do they know the shape of the data that's coming back from the RESTful service? And let me ask you a question. How many times have you called a service and then had to go into the network tab? You know, you had to right click or hit your hotkey, go to inspect, go into network, and then look for that call so you could find out what's in that object. Well, we could certainly do that, but there's maybe better ways. For example, if we know this returns a customer, if we're going to new up that object, in other words, we want to create an instance of it ourselves, then we would probably use either a class or a function to do that, whatever you prefer there, because we need to instantiate it and actually use it ourselves. But if I don't ever need to instantiate a customer, if I'm always getting that from somewhere else, like a RESTful service, and I never need to instantiate it, well, a class, let's do a class here real quick. Let's say we had first name and last name and maybe an age or something like that. Well, notice that actually does generate code here. Now, actually, let me take this out real quick and let's just get our class here. Now, there's a reason this is erroring. It says has no initializer. Okay, and this is also a setting that you can set in here. So I can actually fix this by doing the following. Instead of typing that, we can implicitly say what it is, if that's what we want to do. And we could do something like that. And now when I come up, I could say this returns a customer, like that. Now, you'll notice the customer here, we don't have a return value. Again, the guardrails are popping up. We know that. Let's just return null for now. Okay. And it doesn't like that, though. It's not assignable type customer, but it gets rid of this other red. So notice all these guardrails, again, popping up. Now, where this is helpful, though, is the following. Let's say that we don't ever need to instantiate customer ourselves. Okay, we need to pass it around. We need to get it from services, but we never instantiate it. Why would I want to add the calories here if I really don't need that code that it generates? Okay, instead, we could come in fact, let me just undo this real quick. Okay, let's go to that. And then we're going to change this to an interface now. Okay, now we're saying that whatever get customer returns is a customer. Just like down here, we said if you're going to pass me settings, it had to match the settings for the interface. Okay, so let's say that we'll just simulate this. We call to RESTful service right here, and we return a customer. All right, now I'm just going to hard code the customer. So we'll do this. Now I know I need to return something like first name, last name, and age. I'm going to put what I wish I was if I knew what I knew now. I'm only a few years older than that, folks. You can tell, right? Okay, anyway. Okay, now check out how cool this is. First off, because I said this must have the following shape of data, first name, last name, age, whatever I return from it must match that shape of data. It's a code contract again. So if I mess this up and just did F name and L name, and I forgot to put age, look what happens here. First off, it says, whoa, it's not assignable. Object literal can only specify known properties. F name does not exist in customer. And we go, oh yeah, that's right. It's first name. Now it goes to the next one and same thing, Now let's see what it does. Now the whole thing's red. And that's because I'm missing age. You'll notice in the error there. So how cool is that, that with 0 calories, 0 impact on performance at runtime, our whole team can benefit from interfaces. And I'll tell you, on larger projects, especially, even small, but definitely mid-sized to large projects, in my opinion, interfaces are just essential. I use them all the time. They're literally my #1 favorite part of TypeScript. So we could come and fix this. We could say comma, age, and I could put my fake age here. All right, and then we're good. Now that's benefit #1, but what about somebody who's calling this? So let's say I now come down and say, let customer equals get customer, and I pass an ID. Now, when we say customer dot, look at that. I get phenomenal code help because it knows the shape of the data because of this interface. All right, so that's kind of a quick walkthrough on how easy it is to create an interface, how they have 0 impact on our production performance, and how you can kind of get started with them. Now, I want to show you one little bonus feature. This is something I wish other languages I've worked with, like Java, C#, and others that support interfaces, I wish they did this, but TypeScript does. Remember I left out age? What if age is kind of optional though? Like not every customer is going to have an age. It'd be kind of nice if we could not get an error right there. Well, fortunately we can. We can do this. We can make age optional. All right, we could even come in and make all these optional if we wanted. We could do like that. So one of the nice things about interfaces is, first off, if you don't put this little question mark, which means an optional, in this case, property, then everything's required. It is literally like signing a mortgage agreement where you agreed to pay, $2,000 a month or whatever your currency is to the bank. And if you don't pay, you're in trouble, right? It's very strict. Well, we can loosen that up though, which would kind of like be a mortgage agreement where, if you're 15 days late, it's okay. Like they're not going to come after you. They give you a 15-day leeway. That's kind of like doing this. Now, when I come down to customer here, I'm still going to see all 3. Notice that we have age, first name, and last name, but age is now optional. Up here, I don't have to return it because it's optional. I use that all the time in TypeScript interfaces. Okay, so that's kind of our first look at what we can do with these. And I hope that, first off, gets you thinking about the power. Again, I think of interfaces as, yes, they're a code contract, but personally, I like to think of them as it's more of the shape of the data. It's almost like taking a 3D printer and 3D printing what the shape of the customer looks like. That's kind of like the interface. You're feeding the 3D printer shape, I guess you could say, of that person you're going to print. That's what the interface would do. Obviously, you don't do that with 3D printers, but that's kind of how it works. Now, another thing I want to show you, what if we also have a need to have something called, I don't know, a gold customer, like a really involved customer who's highly engaged with us. They use our services all the time. What if we had that? And I also want these three things in this interface. Well, you could do this. You could copy and paste, but we don't want to copy and paste. That's generally a bad idea. So interfaces can actually extend other interfaces. Now, let's say gold customer, I don't know, we add a is preferred customer something property. Like they're a new gold customer, and they either have preferred status or they don't, based on how much they've spent with us or something like that. It's kind of like, when you do flight miles on airlines or points on hotels, kind of like that. Well, what if I now change this to gold customer? This just went red. What's the problem? I'll give you a chance to read that error message. Property is preferred is missing in type first name, last name. Okay, what's going on here is gold customer now gets all these for free. So gold customer has first name, last name, and optional age, but it adds a fourth option, is preferred. So now I'd have to come in and say is preferred, we'll say true. And now notice the red goes away. So what's nice about this is you can have kind of little Lego blocks. You can have a Lego block called customer, but then you can use that Lego block with another Lego block to make a little, I don't know, bigger Lego called gold customer. And you can build others and others and others. So interfaces can extend other interfaces, but anytime you use an interface, if it extends another one, you have to satisfy the whole contract. So if this thing has three things and this has, this has two because this is optional, age, and this one is our fourth, we'll say, though, then you must put all those. Let's just take this off real quick and I'll show you. So now I have to put all of these in, as you can see there. All right, very powerful because you're not forced to copy and paste between interfaces. You can actually use interfaces to build other interfaces. Now, I'm not going to spend a lot of time on that part. In fact, we're just going to go back and kind of review what we just talked about. But I hope that gives you an idea there. And then I've seen some questions come in. We'll definitely answer those. All right, so here's an example of an iMessage interface. It just has a property called greeting, which is a string. Here's an example of an interface called iGreet that has a function. Notice it's a greet that takes an iMessage, so it takes a greeting, but it returns void. Well, we could now use these. Here be an example of a class that actually implements iGreet. And then notice here that the greet function is implemented. Now let's review this. So there's the iGreet that you saw in the previous slide. It has a greet function. If a class implements an interface, and this is a TypeScript keyword, and keep in mind, I know some of you use classes, some of you don't. So if, like, for instance, if you're using React, you may use classes because that's an option. But if you're using like React hooks, you're not. If you're using Angular, then you're using classes. So it really depends. But the implements is a TypeScript keyword. If a class implements iGreet, it must satisfy the contract. So because the contract said we had to have a greet function here, well, we have to have a greet function. Notice the signature matches. Now, we also know that whatever you pass in, this message is going to have a greeting property on it. Why? Because iMessage has a greeting property. So whatever object is passed in must have that greeting property, just like earlier, the customer had to have the first name, last name, and age properties in order to do their thing. So there's another example of interfaces. Now, I've also shown you how you can extend interfaces. So here's an iAccount that extends iDepositWithdrawal. So now if you implement iAccount, not only do you have to have all this type of stuff, these, well, three things, this is optional, internal ID. You would also have to have whatever iDepositWithdrawal has. So if it had, let's say 4, then you'd have at a minimum 7 things, maybe 8 that you'd have to use when you use this interface. So that's another example I've also shown you. So first off, what is the correct way to name an interface then? Because you've seen me do it without an I and with an I. And the answer is there is no right way. Just be consistent across your team. If your team's already doing, for example, .NET, then you're probably comfortable using I for interface. I personally kind of like it because it makes it very clear it's an interface, but a lot of people don't. For example, if you're doing Java on the back end, you probably don't like I because that's not normal in Java. And so you may not use it. But the bottom line is here, it doesn't matter. What I would care about, having managed many teams over the years, is just, do we have a consistent approach so that we don't maintain code that some people use I, some people don't, and it's just really hard to maintain. So that's my general rule, is have a team rule on how you're going to name things. Would you use an interface or a class if you need to create object instances? Well, the way to answer that, and you probably already know, it's a pretty easy answer, is, does an interface ever run in the browser? No. Only classes or functions or just objects in general make it to the browser. Types never make it to the browser. So you're never going to have that. So you'd use a class in that scenario, or maybe a function, something like that, because the interfaces taste great, but 0 calories. So quick review here. Interfaces are code contracts. They define the shape of the data, as you saw with the customer, with settings I did, with all those types of things. Classes can actually implement interfaces in TypeScript, not in JavaScript, but in TypeScript you can. And that means you're enforcing a contract now. So if the interface had 3 things, the class would have to have those 3 things. And then, like I said, they taste great, 0 calories, because there's 0 impact at runtime, because the compiler takes those interfaces out. They're not used. All right, now I'm going to clarify one thing, and then we're going to wrap up with generics here. One of the things that really threw me off when I got started with TypeScript was I'd see this word called type. And some of you that are doing TypeScript now might have seen this. And then type would look a lot like an interface. And I would just be like, wait a sec, we have interfaces, we have types. What's the difference? And I'll have to admit, for the first probably year of doing TypeScript, I never really took the time to dive into it because I mainly used interfaces. But then type started coming up more. And finally, I, like we all do, finally said, okay, I guess I better dive into this. This was many, many years ago. TypeScript's been out for quite a while. But let me sum it up for you. Interfaces always, always, always represent the shape of the data. Okay, so they're object-like. If you had an iAccount, then the bracket and the bracket, that's your object. And then in this case, we have properties, or we have an iSavings account that extends that, and it adds an interest rate. Well, still, that's an object. You never can use interfaces for just a single simplistic piece of data like a string or a number. They're always representing the shape of an object. Okay, so for most of us, I'm going to argue that's what we work with. If you're building like line of business applications, we do that all day long. We work with objects and objects and objects. That's just kind of what we do. So I use interfaces by far way more than I use this other thing I'm going to talk about, but I want to mention it. What if you had the ability where you need to define a data type, but that particular data type could be a primitive or a custom, or it could be an interface? Well, with interfaces, you only have the ability to define object shapes. That's it. Okay. With types, you can do both. So notice with this type here, we're doing what's called a union type. If you haven't seen this before, in fact, let me just grab this and I'll put it in really quickly for you. Show you an example back here in the playground. So I hope you all can't hear it. It sounds like a lawnmower decided to run next door. So hopefully that's not showing up. But So there's a type account, which could either be a string or it could be an object. That's what we're saying. So now if I come down and say my account equals, 1234A or something, that's totally acceptable. But I could also come in and say, no, this time I need the account to be, and I'm going to have to type this now as an account type. Now notice this goes red. Says you can't assign this because you're missing account number and balance. So now it's acting like an interface. How cool is that? So again, I could either define this as a string like that, and that would be totally fine. Or I could assign it as an object, and now I'd have to put an account number property, which is a string, and a balance, which is a number, something like that. Now it's okay. So that's the main difference between type and interface. You'll notice this kind of is an interface, right? Whereas this is a primitive. Well, with type, you can do either of those. Interfaces, you can only do object structures. So if you come across that, I hope that'll help you out a little bit. That's why I normally use interfaces for like 95% of everything I do pretty much these days. But it doesn't mean I don't ever use types, because there are use cases where you need a primitive or maybe an object shape in a particular case. Okay, another thing you can do with types, which is kind of interesting, is notice in this case, I'm making a type that is is limited to one of two string values, first name or last name. And it's case sensitive, by the way. Now I can define another type, which is kind of like an interface, but you can't do what I'm going to show you with an interface. And I can say, hey, I would like to dynamically, it's called a computed property, say that this person type has first name and last name as strings in this type. So in essence, what it's going to do is it's going to loop through these two and define first name colon string, last name colon string. And now down here, when I go to use person type, I would have to put first name and last name. So if I had first name, last name, and then pipe street or address or something like that, then person type would now have three properties. So this is kind of it's a little more niche topic. We're not going to spend much time on it today, other than to mention that you cannot do this with interfaces. You might come across it with types though. So it's basically a way to dynamically generate computed properties based on other types. So if this had 50 things, then person type could have all 50 of those things. And now we could use it just like an interface. So there's pros and cons to all these. You'll have to choose what you like the best. All right, so the last thing we're going to wrap up with is generics. Generics are code templates. So what is a generic? It's a code template. And that, again, if you're new to this, first time I ever heard about that, that made zero sense to me. Like, what do you mean by code template? Well, I'll clarify it. We're going to see the template part is going to get into this little syntax off to the right here that you're going to see. So here's an example of what I mean by a code template. We have different ways in TypeScript we can define arrays. And with arrays, they could be strings, they could be numbers, they could be customer arrays. Depends on what your collection has. Well, one way you saw earlier is we could do string square brackets, and that would be the type of the array, or number square brackets. I covered this at the very beginning. But another option in TypeScript is we could use generics to define the type of the array. So for example, we could say pets is of type array of string. So if you're new to this, substitute the word of when you see the less than right here. So array of string. Now we can only put string items in the array. Now that would be the most simple example of generics that you're going to come across in this particular technology, in TypeScript in general. So let's talk about some other use cases. What if I had the following? I have a list of numbers class, and notice number and number and number right here. All right, so number and number and number. And then I decide, well, I also need a list of string. So we have string, string. Oop, I think I accidentally hit the wrong key there. There we go. String, string, and string. Would you all agree there's a lot of code duplication there? And if you don't, I'm going to say yes, there is. The only thing that's changing there is the data type, right? We have string, string, and string. We have number, number, number. That's super repetitive. What if we could make a code template that we could reuse like this? Now look at this, T, T, T. And then we have this list of T. Now, if I were to ask you the question, what is T? Well, it's a generic parameter is kind of the official terminology, but what is T? We don't know right now. In other words, if I said, is T a string? Is it a number? You know, what is it? I have no idea what T is at this particular case, because this is a generic template. Now, if we did the following though, if we did new list of string, now I'm telling the TypeScript compiler, substitute every time you see T, here, here, and here, substitute string. And then that's going to put string in for us instead. And ultimately what it would generate is something like this. Notice it kind of strips off our generic parameter and puts string, string, string. Now going back, what if I said new list of number? Well, then over here would be number, number, number. Now let me show you kind of how this can be used real quick. So we'll come back over and then we'll wrap up here. So I'm going to put in this, and then we can say, let, my list of number, for example, equal new list of number. Okay, now I'm telling TypeScript that number is what we want to substitute for T. It will then put T, T, T. Now notice off to the right though, nothing. Generics are only at development time. However, they're very cool because now watch what happens. My list of number dot add, okay? And let's say I said number, right? Notice it says I can only add numbers. Let's add a string. Boom, we get red. Okay, and of course, if I change that to the number, we do something like that, it's going to enforce the number. So why is this powerful? Because now I can use this code in many ways. It's a generic template. We could say string. We could say my list of string. A little typo there, but that's okay. And then list of end string dot add. Notice it only allows me to pass a string, so I can do that and it works. But if I pass like a Boolean, it's not going to work. It's going to enforce that. It adds the guardrails. Now, these are things that I'll have to admit, I don't create my own custom generics quite as much as I just plain use generics. A lot of the frameworks you work with are libraries, React, for example, Angular, Vue. Oftentimes they will use generics in their code, but you may or may not write your own custom generic like I'm showing you here, but at least you'll know when you see those, just substitute the word of, and then tell it, what is the data type I want? And if I were to sum up generics here, they're literally a glorified search and replace. Think about it. If I say new list of string, then it's going to say, all right, compiler, go find T, because that's what we chose for our little generic parameter here. It could be anything, by the way, it could be foo. And every time you find T like that as a data type, replace it with string. Well, if I was to tell all of you, open up your favorite text editor, and every time you find a T type, replace it with string, I think you're all pretty good at that. That's like rule number one to be a good developer, right? Search or replace. That's really all the TypeScript compiler is doing. Now, they add a little more enforcement characteristics, but in reality, they're just doing the replace. They then make sure that whatever code you type only allows strings in this case when you add or get items, do those type of things. All right, now you can also use generics with functions. Just to wrap up here, notice I have a generic parameter. I have a parameter for the function. Right now, if I ask you what is T? What is T? I don't know. I don't know what T is. It's a generic. But if we did this, and we said process data of number, well, now you have to pass a number in or a string or whatever you define for the type. And again, it will in essence do that search and replace as it is comparing your code to what's allowed to be used in the TypeScript. Pretty cool. So you may not, I don't use these nearly as much as I use interfaces or types or even the primitive built-in types, but knowing about generics is really important because you're going to come across libraries, frameworks that are going to be using generics quite a bit. And so now you at least know why you see those little brackets if you haven't done this before. All right, so that's kind of what it would do right there, since we said number. All right, so to wrap up, generics then provide reusable code templates for data types. They're basically provide a way to add some flexibility for those data types. They're compile time only. Again, 0 calories, taste great, you could say. And they can be used in many scenarios. You can use generics with classes, you can use them with functions, you can use them with arrays. There's lots of scenarios where you might use them. And what's really nice is generics can minimize the use of the word any or the type any. A lot of times we'll cheat as a developer. You saw me do this earlier, actually, with settings : any. With generics, we can minimize the use of any, because if you have an object that could be a string or a number or this or that, that might be a good opportunity for a generic, because then you can substitute the type you want instead of just saying any. Because as soon as you do any, you're back to just no guardrails. Like guardrails are down and you crash off the canyon wall, and we don't want to do that. That's a bad way to go. All right, so to wrap up, and then we'll take some questions here. Code examples, where can we get code examples? Well, I have a repo. You can go to github.com/Dan Wahlin, TypeScript demos, and not case sensitive because it's just a GitHub URL. This has a ton of demos. Now, I'm going to give you a better link, though, because you might want to link to the slides as well. If you get a link to the slides, you'll have a link to this. So here's the link you actually want. codewithdan.me/ts-interfaces-generics. That'll get you to the slides, which will also get you to that repo link right there. So I'm going to let everybody take a look at that, and then I'll mention a few Pluralsight resources real quick, and then we'll go into Q&A. So first off, on Pluralsight, if you're new to this, there's a TypeScript fundamentals. John Papa, a good friend of mine, did. In fact, we're going to be updating that really soon as well. There's also a TypeScript learning path up on Pluralsight. So if you just search for TypeScript, you'll find it. Specifically, if you want to focus on interfaces and generics, there's 2 courses. I have one on object-oriented programming with TypeScript, and then there's another one that's just on generics. So if you're interested, go check that out. All right, so with that, I guess, Seth, should we do some Q&A here?
Yeah, let's do it. We have quite a few questions.
A few minutes. So what's the JSON target inside tsconfig options? Yeah, so JSON target, going back, this is the output of what it's going to generate off to the right. Okay, so if you had to target Internet Explorer, and I pity if you have to do that, but some companies might still have to worry about that, then I could switch it to the target to ES5, and then my tsconfig, it's called, .json file. This is my compiler settings. Now notice it completely changed my class. Let's switch back real quick. There's with ES 2017. Well, modern JavaScript supports classes. Older JavaScript does not. So see how it's changing what it generates. That's what that affects. So good question there. Jay, is there any way the IntelliSets can tell you which property is optional without looking at the interface? Unfortunately, I don't think that, that's actually a great question. I don't think they tell you that, though. In fact, I'm pretty sure they don't. Where was our optional? Right there. Yeah, and I remember when I did it, I'd have to try it for sure. This is the project, by the way, which we're not going to have time to really go into, but this is the TypeScript one. If we were to come in real quick here let's go into this interfaces, and let's just do, so here's one that's optional, account settings, notice. So if we did this, let's just make all of these optional really quick. And then if we said, let, my var of type account settings equals, yeah, so the best, it does put the question mark. So I guess it does in that regard. I knew it did that, but I was wondering if it did something different. I couldn't remember. So yeah, it does put the question mark. So you'll have to know that question mark means optional. So excellent question. Is there a way to instantiate an empty interface? No, you cannot instantiate interfaces because remember, they never make it to the JavaScript runtime. So I can't come in and do var, or I always do let these days, settings equals new account settings, because account settings would never, ever be instantiated at runtime. Now, if we change this to a class, we'd have to fix up some stuff here. Then you could, because classes make it to runtime. But interfaces, yeah, they never make it to runtime, so you can't do that. So excellent question. Okay, excellent question, Zachary. The question is, I showed types and interfaces, and Zachary asked, he was curious about the benefits of extending an interface, and I'm actually showing an example of that right here. Account is extending account settings and deposit withdrawal. So now whoever implements account, they get these two functions. And then, well, these weren't all optional before. Let me undo that real quick. There we go. And then these would be required right there. These are optional. So it really depends, Zachary, if you're worried more about the shape of objects, I think interfaces are the way to go because that's really what they're designed for. However, if you have that combination, you could make a type that says, something like this, my custom type equals, and then we have maybe deposit withdrawal or account settings or something like that. You could totally do that. But now whoever uses this, if we do let my var of type, my customer type, they're not getting both of these merged. It's one or the other. So now I'd either have to make an object that matches this shape, or I'd have to make an object that matches this shape. Now, there are other things I could do there, though. I could merge them with types. So to be honest, I think interfaces are a little more suited for that. But, Zachary, if you prefer types for that, it wouldn't matter. You're going to get the guardrails, and that's all we care about. I would just offer that as a team, you should try to be consistent there. If you have that scenario come up, like don't have, Zachary, you're doing type and I'm doing interface, and now we're all confused. I would avoid that. Alejandro, in what cases would you recommend using interfaces versus abstract? Yeah, excellent question. Now, I didn't go into abstract classes mainly because I didn't have the time. I have one, though, I think right here. So an abstract class, this is a class, okay? In fact, if I, let's do this real quick. And I'm going to have to strip out. Well, I'll just type one. Let me just type one real quick. So we'll do class, abstract class, customer, something like this. First off, an abstract class is the building blocks for other classes. So if you intend to inherit from this class, in other words, I want to make another class called gold customer that extends customer. In other words, it builds on top of it. So let's say customer has first name and last name, like this. Yeah, I got that other setting on, so I'll have to give it an implicit type here or value. Okay, now gold customer automatically gets those. Now gold might have the is, or I don't know, can do special things, can get special discounts, for example. And we'll default that to true because they're a gold customer. Well, now if I come down and say, let my customer equal new customer, watch what happens. It goes red. You cannot instantiate a base class. Now, I haven't answered your question yet, but I'm getting there. Okay, but I can come down and instantiate a gold customer. And now gold customer has the first name and last name inherited, prototypal inheritance, because we extended customer. So if your goal is to inherit functionality that can also be used at runtime, abstract classes are great for that because they define that base functionality and then other people on your team can inherit it and just get it for free. On the other hand, if you know you never need to instantiate it, again, you just want to define the shape of the data, such as the shape of the customer, but you know you're not ever going to instantiate it with a new keyword or something like that. You know, you might make an object like this. That's instantiating technically, but if that was typed as an interface, I'll just put interface here. Now we would get the benefit of the guardrails, and we have to put the properties or functions this interface has. So I'll sum it up because it's a great question. I'll sum it up by saying, if you need the functionality inherited so that we can instantiate other objects with it, I think abstract classes are a good way to go, but you need to understand that that's going to add more code. See all this code that was added here? Whereas interfaces would add zero code. So if your goal is just, I want to enforce the consistency, I'd go with interfaces. So I hope that helps a little bit. Okay. Chris, how would you implement an interface on functional React components? Is it just function, name function, implements, interface? No. So functions aren't going to ever implement an interface. The only time you're going to do that is on a class. So if I had, interface foo, and I have class my foo implements foo, foo. Come on. There we go. And now if I put in, first name string, well, now I have to put first name string, or better yet, do that. With a function, what you would do is this. If you had a function and it, I don't know, we'll just call it foo, and it returns an object of shape foo of the interface, then you would do this, but you would have to return this, object. So we'd have to return something like this. First name, like that. So you won't implement an interface. You will simply either use the interface in the parameter signature, or you'll use the interface as the return type. So hopefully that helps out a bit. Rahul, let's see. What is the way to put some custom logic in generic class function based on passing the type? You really can't. The only thing you can do is generics. Here'd be an example of a generic where now I could say let customer equals new customer of string. Okay, but you can do some more tricky stuff here. So for example, if you just put T, then you can pass anything in for the data type. Foo, if that's an interface or a class, fo, fum, anything. If you want to lock it down, there is some more advanced functionality you can do. And this is kind of off the top of my head because I don't use this as much. I think it's something like that. Yeah. So now watch what happens if I pass string. Well, actually, I didn't expect that. I expected it to error. Well, I'll have to go look that up. But you can basically say, you can pass me something that has this functionality. In this case, foo. Now, maybe it's because I don't have anything in there. Yeah, there we go. It's because foo was empty. So now you can't pass string. You can pass something that basically implements foo. So if we had another interface called fo, and it had last name, or sorry, it's extends on this. Now I could only pass an object that, like fo, would be acceptable, or foo would be acceptable. Now you can do that, but that's about it. Everything else is pretty locked down. And cut me off, Seth, as soon as we have to cut off. I'll keep going until you tell me to stop.
Yeah, Dan, honestly, however many you would like to answer, I want to make sure we respect your time too. It looks like we have about 4 left. If you want to,
yeah, we can do those.
Awesome.
No, we can do those. Absolutely. So, Raul, I hope that helps a little bit. There's not a lot of custom tweaks you can do with generics aside from you can lock down the type that's passed in. That is optional. Functions and stuff, though, the best you can do there is have a generic where I showed earlier. In fact, let me just jump back because it's right here. I showed this earlier where you can have a T and then you could say my function of type. You could also do that extends right here, extends some interface. Let me make that a little more readable for you. But that's about it. There's not a lot of other custom nature to generics in this case anyway. So hopefully that helps. Yeah, Blake, that is an excellent question. And you saw me actually kind of mess that up, I guess you could say. Let me see if I can undo here. Remember earlier, just a moment ago, I did this. Right? And I said, oh, yeah, I can't do that. That's wrong. It's extends. So it's kind of interesting. Extends is an ES 2015 keyword. Okay, so first off, that is, in other words, that is part of JavaScript. Implements is a TypeScript keyword. No JavaScript support. 0. So it's interesting here that, yeah, why didn't TypeScript why did they choose extends instead of an interface implements, another interface? And we would have to talk to someone like Anders Heilsberg, who invented this. I'm sure there's a good reason. Probably they wanted to use the keyword that's already part of the language, part of JavaScript is my guess. I actually don't know the answer to that though. But the bottom line is the only time you're going to use implements is on classes. So I can do implements faux because faux is an interface. If faux was a base class, like an abstract class, like I showed earlier, then I would have to use extend. So if we change this to abstract class foo, well, let me change that to foo. Now I would have to put extends because it's a class. So the bottom line is extends is for classes and extending interfaces. Implements only for classes in TypeScript, actually, not even JavaScript. So hopefully that helps a little bit. All right, Raul, let's see. TypeScript enum generates lots of JS. Yes. Yeah, there is a workaround. I don't know if it'll work for you, Raul, but there is a workaround and it's related. We're talking about types today, so it's good. Yes, let's do an enum real quick of, I don't know, let's say we had pets or something like that, values, or yeah, that'll work. And we have dogs, cats, birds, and chimpanzees, because, you know, that'd be fun. Or chips, because I can't type today. All right. Now, look at all this code on the right. And for those that aren't familiar with this, this is what Raul's talking about. See all this code it generates? It's nice because I can come down now and say, let, you know, my pet of type pets equals pets dot, and now I get IntelliSense. So instead of having what I call magic strings, where people would actually type something, and then if they have a typo, like case is different, you know, that messes things up, we could instead make it where they can pass this enum value. So if we wanted dogs, because I'm a dog lover, we could do something like that. Or maybe you have a function that is add pet, and it takes a pet type of type pets, right? Something like that. And now when we call it, it would be pet type, and I'll get to you. I haven't answered your question yet, but I'll get there. I'm going to show you the difference here. Or sorry, we would pass in not pet type, but pets dot, dogs or something. That's the benefit of enums. It prevents magic strings, but it does tend to generate quite a bit of code. Notice it's arrays of arrays. There is a workaround, Raul, but I don't know if it will. It depends on how you use them. Normally, if you use this, you log pet type. And let's go ahead and run this. Let's go to our logs here and we'll hit run. See how I put out 0? And that's because dogs is 0, cats is 1, 2, 3. So let's change it to chimps. And let's run it. And now notice it's 3. So for you, Raul, if you're only after the numeric value, then I'm going to show you a trick you can do. Now watch the magic here. Look over to the right. Nothing up my sleeves. This is my magician trick. I'm going to change this to a const enum. Whoa, look at the difference in code there. There's before. There's after. Now here's the kicker though, Raul, and this may or may not meet your needs. Because it's a const enum, what they're doing is when I said pets.chimps, it went 0, 1, 2, 3, and it literally hard-coded 3. So if you're only after the numeric value, this is phenomenal. Maybe that's what you store in the database, for example, because you can even assign, let's come down here and I'll just show you real quick. You can even assign values that maybe equate with your needs at work. So let's just do 40, 50, 60, 70. Now notice it hard-coded 70. So if that's okay for your needs, Raul, then you can do a const enum. Otherwise, no. You'll have to, if you need the string value in addition to the number, because you can convert between the two with this option. So hopefully that helps. All right, Gustavo, let's say I need to call endpoints from an API and I want to have the interface of the object returned. Excellent. I highly recommend that. Well, I always have to create these interfaces manually. Sadly, yes. Either A, your backend code, if you're kind of in a more sophisticated setup, they could actually generate the interface for you so that when their API changes, they publish an interface package and then you just update to the latest package. That would be something you'd have to build into your workflow. And I realize, for example, if we go to swappy.dev, this is the Star Wars API because, can't get enough Star Wars. And if I hit request here, there we go. See this data? That's not even that big. Let's go back to here. I think it was Luke or something like that. And it kind of looks like, oh, well, I want to get rid of that. All right. Well, if I want the IntelliSense for this JSON data coming back, basically the question is, how do I do that? Do I manually do it or is there another way? Well, like I said, the API, if it's written in Node.js, you absolutely could kind of automate because you could use TypeScript with Node.js and actually share those interfaces between the server side and the client side if you wanted. But if you're using Java, .NET, Python, PHP, whatever you're using on your backend, you'd have to build in that process. Now, let me show you if I can find it. It's like JSON. Yeah, I think that's it. Actually, you can see I go to these a fair amount. JSON 2TS, I think. Yeah. So JSON and then number 2, ts.com. This is pretty cool because what it will do is you can paste in your JSON data and then hit generate. Uh-oh, it seems like there's an error. Where's the error? Oh, semicolon. And it will actually generate the interface. And there's even others. There's another one I use, and I can't remember the website name. Yeah, but this one works. There's another one that's even better, but I'd have to go to some other slides to find that one. I have it bookmarked, but But anyway, there are some, if you use VS Code, there are actually some extensions. You'd have to search for these, but they're out there where you can just do a hotkey on the JSON and it will automatically generate the interface like you see right here. If I could think, this other website's not a very intuitive domain, but it's really good. If I think of it, I'll let you know before we get done, but I don't think it's going to happen. So hopefully that helps. Fabio, is it possible to extend an interface and a class at the same time? You can't extend an interface with a class, but you can extend, in other words, you can extend an interface and you can implement it. Let me just show you. If we had an interface called customer, and it has first name string like this, and we have a abstract class, let's say, called base customer. All right, I'm making up something here. Oops, I need class. And it has, I don't know, last name. This is a horrible example of architecture, but I'm trying to be quick here. And then we have our class gold customer, extends base implements customer. All right, you can absolutely do that. And then if you had multiple interfaces, you can even do comma, chameleon, if you know that song. Horrible reference, sorry. But anyway, yes, you can do that. Now on an interface, you can only implement other interfaces like this. You can do that on interfaces. But on classes, the extends will be first, then you put the implements, and then you could put comma, chameleon. Anyway, you don't want to hear me sing today, so. All right. And if you don't know that song,
Dan, we got more time if you want to sing.
I'm thinking not, and I'm thinking half the crowd's going, "What the heck is he talking about? I've never even heard that song." And then the older crowd's going, "Oh yeah, I know that song."
live coding and karaoke. That's an idea, though. That would be interesting.
I like it. We should start that up. We could do new webinars. Right. You know?
I'm sure we have some
other.
I think that
gets through the questions. So let me go back just to wrap up, and I'll let you take over here. So again, the one main slide you need for those still sticking around, or the one main link is right here, TS interfaces-generics. So with that, I will thank everyone for coming. I hope you are able to leverage these skills. Once you get the hang of it, I'm telling you, I'm not going to say it'll change your life, Seth, but it's close. It's close. It'll change your developer life. So
that's awesome. Well, thank you, Dan, for taking the time and for answering so many questions. I just looking at the chat now, and I know everyone that's attended is very appreciative of your time too. And so just as a reminder to those still in here, we will be sending out a recorded version of this webinar to the email that you signed up with. And we'll also make sure to gather Dan's deck too, to share with you via email. If you, for some reason, don't record these URLs. So Dan, any final takeaways before we sign off, or any final thoughts?
You know, I guess my final thought would be, don't feel like you need to use these right away. Like everything with programming, this is kind of your Batman tool belt, right? And now I have interfaces, I have generics, I have types, and I use them when appropriate. So don't invent reasons to use these. But I'm going to tell you, to wrap up, there are plenty of reasons why you might want to use these. But again, use them when appropriate.
Great advice. All right. Thank you, Dan. And thank you, everyone, for coming. And